Hello viewers, welcome to Unacademy YouTube channel. Myself R.Vetrivel, Unacademy plus physics educator. Welcome all once again the India's best online platform coaching. Viewers, today we are going to discuss the important capsule concept on electric charges and field. Before going into that, just I preview the plus subscription of Karnataka CET. So, right? Best plan for Karnataka Common Entrance Examination 2021 aspirants. It is the best opportunity you can catch up the top educators in Karnataka who can train you to get very good score in KCET. Right? For that, you have to subscribe the Karnataka Common Entrance Examination plan plus subscription in Unacademy. Right? So here there are 12-month plan and 6-month plan and 1-month plan. Have a try and use my code R.Vetrivel Ramanathan, Vetrilive, right? Use my code as a Vetrilive to subscribe Unacademy. Here the premium content at affordable price, that is the most important, right? It is affordable price, structured live courses and dedicated live doubt clearing session, quizzes at a regular interval and with self-analysis, batches for complete preparation, test series for daily practice tests, full-length mock test with analysis, single subscription for unlimited access. So all the aspirants use my code Vetrilive and subscribes Unacademy and you can enjoy unlimited access for all the subject. Right? And today I am here to give you the brief input of intensity of electric field. We are going to discuss today the first chapter, the most important concept in that, which is every time expected in all the competitive examination. Right? Intensity of electric field. Right? In a region, suppose electric field, the space or a region in which its influence can be experienced. We all know the point charge whose size is so small when compared to distance travelled between them. This point charge can produce electric field around it, or we can say in a region, right, within the electric field, consider a point. Now a test charge Q naught, which is used to test the presence of electric field. A test charge, whenever you bring, it experiences a force. The force experienced by the test charge is directly proportional to Q naught, test charge, right? So this F is equal to E into Q naught. When proportionality make equal, right, we need to write a constant where E is constant of proportionality called intensity of electric field. Another name, electric field strength, or right, intensity of electric field. From here we can write this E equal F by Q, Q naught or Q. The force experienced by the unit positive charge placed at that point. Where is that point? Within the electric field. So the electric field or the electric field intensity or intensity of electric field or electric field strength at a point in a region, the region where electric field is present. Electric field intensity at a point in a region is defined as the force experienced by the unit test charge or unit positive charge placed at that point. So electric field. We know electric field is a vector quantity. Electric field always directed from positive charge towards negative charge, right? So electric field, SI unit of electric field is force per unit charge, Newton per coulomb, force Newton, charge coulomb, or there is another unit, volt per meter, right? So we know that relation electric field equal V by D or L, right? Remember, this is relation between electric field and electric potential. So here volt per meter, that is why that's a 2 unit I showed you, electric field or intensity of electric field, Newton per coulomb or volt per meter, right? So this very important. If the charge is positive, then see that if it is a positive charge, then the direction of electric field, if I consider one point P, right? So this charge produces electric field, the point P is within this, so it experiences, the direction of electric field will be from positive to, right, always it will move, the charge is Q positive. If the charge Q is negative, then at point P the electric field will be always directed towards direction of electric field, right? Okay, now electric field intensity due to an isolated point charge. We know electric field now, force experienced by the unit positive charge placed at that point, E equal F by Q. We know electric field. What is that electric field intensity due to an isolated point charge, right? Consider a point charge Q. We all know point charge means the size of the charge is so small when compared to distance travelled by it, right? Source charge means the charge which produces electric field. We know that point charge always produces electric field which is static. When the charge is motion, it has, apart from electric field, it has magnetic field also. Now the point charge you consider, so it produces electric field, right? Now this point charge is placed at point A. Now within this electric field, consider a point P at a distance R. At point P, I am placing the unit test charge Q naught. Now we can utilize Coulomb's law of electrostatic force between these two charges. Charge Q is placed at point A, right? Within this electric field, consider a point P where a test charge is placed Q naught at a distance R. Now the force experienced, that means force between these 2 point charges will be, we know according to Coulomb's law, right? Coulomb's law of electrostatics, 1 by 4 pi epsilon naught Q naught by R square, right? So now according to electric field, we know that electric field equal to force experienced by the unit test charge. Now substitute this F value here, right? So electric field equal force by test charge. This Q naught will get cancelled. You will get electric field at a point P due to the charge at A is 1 by 4 pi epsilon naught Q by R square. This is electric field at a point due to an point charge, isolated point charge, electric field formula, right? 1 by 4 pi epsilon naught Q by R square. If charge Q is positive charge, this is, if the charge is positive, then electric field is along, we consider a point P, right? Here positive charge, it produces electric field. Now consider a point P at a distance. Now electric field is along the direction, right? A to P, right? See the direction of electric field. If suppose the charge Q is negative, then electric field is along P to A, directed towards negative charge. So this point has an idea now. If E is electric field at a point and charge Q is kept at that point such that the force acting on the charge is F, we know that, right, within the electric field if you bring any other charge it experiences a force. The force experienced by the unit positive charge within the electric field is F equal to QE, right? If Q is positive, the charge is positive, then the force parallel to electric field. If it is negative, then it is parallel to negative electric field. If m is the mass of charged particle, then the acceleration of the charge in the uniform electric field, you consider a charge q, right, having mass m, velocity v, moving, enter into the uniform electric field. Assume the region where uniform electric field. What is uniform electric field? The magnitude and direction remain constant throughout the region, uniform electric field, right? Between the parallel plate of the capacitor, right, you will get uniform electric field, right? Example, the magnitude and direction remain constant, uniform electric field. If it is non-uniform electric field, the magnitude and direction vary, right, differ. A positive charge, suppose a positive charge draw the electric field due to a point charge, it will be radially outward electric field, right? It is non-uniform. Now the charge Q enter into the uniform electric field, it experiences a force. We know that, right? Electric field equal, right? It experiences a force F equal to QE, right? So it along with it has the acceleration also. The charge mass m, right? Then it accelerate in the uniform electric field. The acceleration is given by F by m. F is QE by m. Then a proton and electron when left in the uniform electric field, both will experience the same force and magnitude. See that? Proton, we know, positive charge, and electron, right? Both are left in the uniform electric field, proton and electron. Both experiences a force in magnitude but opposite direction, because electron negative, proton positive. They experiences different acceleration because their mass is different, right? So they experiences different acceleration in magnitude along opposite direction, right? Both has the magnitude, but they experiences different acceleration in magnitude in opposite direction. So when proton and the electron left in the uniform electric field, both experiences same force in magnitude but opposite direction, but different acceleration, moves in opposite direction, right? This has an idea. Now null point or neutral point, right? The point where the intensity of electric field becomes zero. What is a null point or neutral point? In a system, if there is a n number of charges, right? What happens? The electric field due to the number of charges producing, the point where the net electric field becomes zero, that is called null point or neutral point. You assume in case of a system, that means system of charges, n number of charges are there. In case of a system of charges, the net electric field at a point is zero. That point is called null point or neutral point, right? Now the 2 point charges, assume, right? plus q, like charges, 2 point charges plus q1 plus q2 separated by the distance r, right? Now, two like charges. Now, at what point line joining these two charges, the electric field intensity becomes zero? Let the point, we don't know, the line joining the two charges, at what distance it will occur. We will take the point, suppose the point P, where the electric field due to these both charges become zero. The point P, that is a null point, at a distance q1, it is at a distance x. The remaining distance will be r minus x. Now, what is the electric field at point P due to this positive charge q1? It will act along, right? E1. Now at point P, due to second charge, right, like charges, it will repel. This is direction of E2 due to second charge, right? So now at neutral, that means at equilibrium position, what happened? The intensity of electric field due to first charge and second charge is equal to 0. That is only null point or neutral point, right? Now E1 is equal to minus E2, right? Or if you take mod, we know that E1 is equal to E2, right? What is electric field at point P due to first charge? We know that 1 by 4 pi epsilon naught q1 by x square equal E2 1 by 4 pi epsilon naught q2 by r minus x whole square, right? If you simplify, right, this cross multiply, finally you will get at what distance the electric field becomes zero, null point, right? X equal to distance r by square root of q2 by q1 plus 1. So this is the shortcut formula to calculate the null point, right? It will act along the line joining the two charges, right? It will always lie closer to the lesser magnitude charge. Which charge is lesser magnitude? That side the null point will occur, right? So the point where the intensity of electric field due to this 2 point charge is 0 is called null point or neutral point. Clear? If it is unlike charges, suppose plus q charge, other is minus q. If it is unlike charges, the null point will occur outside the line joining the two charges, which is lesser magnitude. Suppose it's a q1 positive, q2 negative. Assume q2 is less than q1. Then the null point will occur at point P, outside the line joining the two charges at a distance x, right? This will be r. Now electric field at point P due to q2 will act towards, right, E1. Electric field at point P due to q plus q1, it will act along this direction, right? So same, we can do that, right? 1 by 4 pi epsilon naught, both side common. So what is the electric field at point P due to q2, right? Right, we will get q2 by x square equal to that side q1 by r plus x whole square, right? Simplify, you will get x equal distance, right? That is r by square root of q2 by q1 minus 1 you will get, right? This difference keep in mind. If it is like charges, root q1 q2 plus 1. If it is unlike charges, you will get minus 1. That's the difference, right? So let us see now. Intensity of electric field we discussed, right? Now this in general formula, x equal to r by square root of q2 by q1 plus or minus 1. Plus sign is used for like charges and negative sign used for unlike charges, right? So next is Unacademy Plus. Are you a Plus subscriber? Right? So no need to delay. Today itself you can go for use my code R.Vetrivel, subscribe Unacademy. You can enjoy the benefit of this, right? It is affordable price and batches for complete preparation, everything under single subscription for unlimited access. So use my code and subscribe Unacademy and you will crack CET, right? Here the next concept, in case of motion of the charged particle enter into the uniform electric field, right? Whenever the charged particle enters in the uniform electric field, here the electric field is acting vertically downward. If I drop a charged body from rest, so its total weight mg is balanced by electrostatic force QE, right? That's only represented here, right? Where electric field is present, if the point charge is released, it experiences a force. At equilibrium position, this charged particle is balanced by its weight mg and force, right? Electrostatic force. Now, if the charged particle is under equilibrium position, then under equilibrium position you can equate it both. Its weight is equal to QE, right? From that we can find out electric field or whatever required in problem. See that from this Q equal to NE, right? So here Q equal to NE into E, that is equal to mg. If you want to find, right, number of electron, then mg by EE, electron charge and electric field, right? Let us see now, based on this concept so far what we discussed, some of the problem, let us see. It will very useful for your competitive exam. So first one, here it is. Calculate the electric field intensity which would be just sufficient to balance weight of an electron. If this electric field is produced by second electron located below the first one, what would be the distance between them? Charge of electron given, mass of electron given, and acceleration due to gravity is given. So here according to problem, electric field intensity which would be just sufficient to balance the weight of the electron, right? So a force on an electron in the electric field, we know F equal to QE, right? So here it is just balancing, its weight is given clearly, right? See the charge, its weight mg is balanced by QE. So QE equal to mg at equilibrium position, it's balanced, right? From this, what is electric field? Electric field equal to mg by q. Q is nothing but electron, charge of electron. M is given, mass of electron is given 9.1 into 10 power minus, right, minus 31. This is mass of electron 9.1 into 10 power minus 31 kg, right, into G value we know 9.8 by Q, charge of electron 1.6 into 10 power minus 19. You will get 5.57, right? 5.57 into 10 power minus 11 volt per meter electric field you will get. Now the charge E, what we got now, the charge is just here is balanced, we got it now, electric field. Now below, see that second electron is located below the first one. This is first electron. Now on the same line, second electron is located below this. The distance between these two electrons is R, right? What is the question they asked to see that what would be the distance between them, right? Now we know electric field equal 1 by 4 pi epsilon naught Q by R square. Distance we need to find. Already we know electric field. So from that R square, bring it up. E exchange it now. Right? R square equal 1 by 4 pi epsilon naught Q by electric field. That's it. R equal to square root of. That's all. So all the values given. Right? Square root of 1 by 4 pi epsilon naught, we know 9 into 10 power 9. So directly that value you can substitute. Right? So 1 by 4 pi epsilon naught, we can substitute directly 9 into 10 power 9 into Q. Q values we know 1.6 into 10 power minus 19 charge of electron. Right? By electric field already we found 5.57 into 10 power minus 11. Right? So you will get the correct answer 5 meter, the distance between the two electrons. Right, let us go for the next one. 2 point charges separated by 30 centimeter. Q1, Q2 is given. Find the point where the strength of the field is 0. That's the meaning. Intensity of null point is the question. Find the point where the strength of the field is 0. Line joining the two charges. 4 microcoulomb is 9 microcoulomb separated by 30 centimeter. At what point electric field intensity becomes 0? So directly we can go. We know the shortcut formula. The point at which electric field intensity becomes 0. R by, right, square root of Q2 by Q1 plus 1. That's it. So R is, we know, 30 by square root of 9 by 4 plus 1. Right, that will become 30 by 9 by 4, 3 by 2 plus 1. You will get 5 by 2. 5, the 2 will come up. You will get that answer 12 centimeter. Null point will occur. Right. So direct formula you can do. Find the force experienced by the chloride ion having 4 electrons removed when placed in the electric field 2 Newton per coulomb. Electric field is given. Right. Find the force experienced by the chloride ion 4 electrons removed. So 4 into charge of electron. So very simple. What is the force experienced in the electric field? F equal to QE. We know that. What is Q? Right? Electron. How many electrons? 4 electrons are removed. 4 into charge of electron. 1.6 into 10 power minus 19 into electric field 2. That's it. Right? You will get, right, 12.8 into 10 power minus 19 Newton. Right? Let us go for the next one. 2 horizontal plates. Question, read carefully now. 2 horizontal plates parallel, right, 10 mm apart. See that horizontal plate. This is 10 mm apart. Right? The distance is given. 2 plates. One is say positive, another negative. The 2 plates. Now see positive, negative plate, what positive potential and negatively charged oil drop is given kilogram and is held stationary between the 2 plates. So here is a negatively charged oil drop is held between these 2 plates. So what happened? What are the forces acting on this oil drop? We know. In the oil drop, its total weight mg will act vertically downward at neutral point. That means at equilibrium position, the right force, right, in the electric field QE will act vertically upward. Separation given. What is the potential? It is 1000 volt. Potential difference maintained. We know Q equal, right, at equilibrium position QE equal to mg. Right. From that, see, we know already electric field is V by D. Right, what is potential? It is 1000 by D. 10 millimeter separated the plate. 10 into millimeter, 10 power minus 3, right? You will get electric field 10 power 5 volt per meter. You will get electric field. Now charge is the question, right? We know that formula. See that at equilibrium position, we know that QE is balanced by weight of the oil drop, mg. From that, what is Q, right? mg by E. That's it. All the value is given. Mass of electron we know. Here m is given. In the question is given 4.8 into 10 power minus 15 into G value 10. By electric field just now we found 10 power 5. You will get, right, here answer 4.8 into 10 power minus 19, right, coulomb. Then we know that number of electron is the question. Q equal to quantization rule. Q equal to Ne. From that N equal to Q by E, charge of electron. That's it. Q value is given just now. 4.8 into 10 power minus 19 by charge of electron. 1.6 into 10 power minus 19 coulomb. You will get 3 number of electrons. Right. And the next one you see that a particle of mass is given, charge is given, is thrown into the speed is given, where it is thrown into the uniform electric field strength. Then what is the force experience whenever the charge moving into the uniform electric field? Both values given. Q is given, electric field is given. You will get the answer 1 Newton. Q is given, we know 5 into microcoulomb, 5 into 10 power minus 6. Right? E is given, electric field 2 into 10 power 5. Substitute, you will get 1 coulomb. Acceleration F equal to m into A. Acceleration A equal to F by m. You will get minus F is 1, m is minus 10 power 3, right? 10 power 3. You will get minus 10 power 3 meter per second square acceleration you will get. V square minus U square equal to 2as. We can use for distance. Distance S equal V square minus U square by 2as. Take it distance. That's it. V square final is 0. It is moving with the speed. Initial velocity is given 20 square by 2 into acceleration minus 10 power 3. That's it. You will get 0.2 meter. Right? And that last one, a pendulum of pop 80 milligram is carrying the charge. You see that? It is a pendulum of charge. Slightly you pull it one side. Right? At this point, charged one. Its total weight is acting vertically downward. It is moving in the electric field. So the force, tension will act along. This is the angle theta. Right, this is the mean position. From there the bob pulled one side making an angle theta. Now tension acting there. This tension can be resolved into two components. Right, vertical component, that is T cos theta, because since this is theta, this angle also theta, and horizontal component T sin theta. Right, so the force QE, since the bob is oscillating, it experiences QE. See here, find the tension in the thread and how much angle it makes. So here, which are the forces are balanced? See that first equation, T sin theta is balanced by QE, right? Equation 1. Second, vertical component, T cos theta is balanced by mg, right? Equation 1, equation 2. Divide equation 1 by 2, T cancel, sin by cos, tan. So tan theta equal QE by mg, theta equal tan inverse of this QE by mg. All values are given, right? Theta we can find. Theta equal tan inverse of Q given, charge, right? E also given, m, mass of electron we know, given, and G value 9.8. Substitute, you will get theta will be 0.51, that is tan theta. Theta equal tan inverse of 0.51, that will be 27 degrees Celsius approximately. You have to see logarithm book, right? Natural tangent, you can see, you will get that angle. Tension, what is the first equation I balance? Horizontal component, you see here, horizontal component, right? So the horizontal component, you can see, the horizontal component P sin theta is balanced by QE, right? So from that tension T equal QE by sin theta, QE by sin theta, right? All the values given. Q is given charge 2 into 10 power minus 6 into electric field is given 2 into 10 power 4, right? By sin theta. Sin, already we know theta value 27 degree. You have to see the logarithm book. Sin 27 natural sine value substitute. You simplify, we will get 8.81 into 10 power minus 4 Newton, right? So today we discussed electric field intensity concept, right? I hope these problems will be very helpful for you for all the competitive examination. This concept you understood today clearly. So I appeal all the viewers, champion patch is already going on. So learn from the best educator of Karnataka CET, detailed explanation with each topic, better understanding, complete syllabus coverage, that is more important, tips and tricks and time saving, and you will score better in exam. At least have a try for 1 month trial plan, right, at the affordable price. Use my code VETRILIVE, right? Don't forget, use my code VETRILIVE to subscribe Unacademy. We will meet you the next class with that other concept. Till then, have a nice day. Thank you.